Hi and welcome to this second video on concentration. There is more content, quizzes and past papers on the website, which is www.elevise.co.uk. So this is the second video on concentration, so make sure that you've looked through the first one before you come onto this video. So let's just have a quick recap. Concentration is a measure of how much of a solute we have in a given volume. A greater concentration means that we have more of a solute in a given volume. A lower concentration means that we have less of a solute in a given volume. So let's have a look at the formula triangle. At the top of the formula triangle we have mass, and mass is measured in grams. At the bottom of the formula triangle we have volume and concentration. Volume is measured in decimeters cubed, and concentration is measured in grams per decimeter cubed. So why is concentration actually important? Concentration is important because of standard solutions. Standard solutions are solutions that have a known concentration. For example, the acids and alkalis that you use at school are going to have a known concentration. We are able to make standard solutions if we know the volume and the concentration that's required. For example, what mass of a solute do we need to make 300 centimeters cubed of a solution with a concentration of 120 grams per decimeter cubed? The first step to answering this question is to work out how much of the solute we need. Here is the formula triangle from earlier. Pause the video now and have a go at working out what the mass is. So to find out the operation that we undertake, we cover up what we are trying to find on the formula triangle. In this case it's mass, so when we cover up mass we see that we need to multiply the volume by the concentration. Volume should be in decimeters cubed. Currently the volume is in centimeters cubed, and to convert it from centimeters cubed to decimeters cubed we divide by 1000. So we divide 300 by 1000 and this gives us the volume of 0.3 decimeters cubed. The concentration should be in grams per centimeter cubed, and this is what is currently in. So to work out the mass we do 0.3 times 120. This gives us a mass of 36 grams. So now we know the mass of the solute that we need. We now need to make the solution, and here are the steps. The first step is to place a beaker on some scales and reset the scales to 0. We then add the correct mass of the solute, which is 36 grams. The next step is to add deionized or distilled water. Deionized water is water that has had all of the mineral ions removed. Distilled water is water that has been evaporated and condensed in order to purify it. We add a lower volume of water to the beaker than what we need. For example, we want to have 300 centimeters cubed of water. Therefore, a good amount of water to add would be 200 milliliters. Remember that 1 milliliter is 1 centimeter cubed of liquid. We stir the solution until all of the solute has dissolved in the water. After all the solute has dissolved, we pour it through a funnel into a volumetric flask. We need to choose the correct flask for the volume that we are measuring. We also use a funnel, and this is so that we make sure that all of the liquid is poured into the volumetric flask and none of it is lost. The next step is to rinse the beaker and the rod that we have used to mix the solution in with distilled or deionized water. This is so that there is no solute on these two objects. If there were solutes on these two objects, it would mean that the final solution would have a lower concentration than what we require. We then pour the water that we have used to clean the rod and the beaker into the volumetric flask. In this step, we need to ensure that we do not use too much water. This is because if we add too much water, it means that when we put it into the volumetric flask, we're going to have a solution that has a lower concentration than we actually want. Therefore, in our example, we could use 75 centimeters cubed or 75 milliliters. This brings us on to step number 5. Step number 5 is where we add deionized or distilled water to the volumetric flask. This is so that we have the correct volume of our solution. The water will be curved at the side of the top of the volumetric flask. This is known as meniscus. When we are measuring the volume in the volumetric flask, we need to ensure that the bottom of the meniscus is level with the volume mark on the flask. When we are getting close to the correct volume, it may be easier to use a drop-in pipette to ensure that we do not add too much water into the volumetric flask. This is because if we add too much water into the volumetric flask, it means that the concentration of our solution will be too low. As soon as you have added the water, you cannot take it away. Therefore, it is better to add water in little doses and it take longer rather than adding too much water and then you have to do the whole thing again. When we have the correct volume, we're then on to the final step. The final step is to hold a stopper in the top of the flask and to turn the flask upside down. This is to mix the solution so that the solute is evenly spread out within the solution. This brings us to the end of this video. For more content, quizzes and past papers, go onto the website, which is www.elevise.co.uk.